Good evening. Good morning. It's time for our CHM 1 2. I have to share the slides. I believe you can see my slides. Hold on, let me go. Slideshow. So you're welcome again to this lecture, CHM 102 lecture on determination of structure of organic compounds, including qualitative and quantitative analysis in organic chemistry. So determining the structure of organic compound is very essential for the understanding of chemical behavior, the synthesis and application of such compounds. And the structural determination involves qualitative analysis, quantitative analysis, spectroscopic and chromatographic methods. And we see applications of this span across pharmaceuticals, forensic science, food chemistry, and environmental monitoring. Because qualitative is just to identify which elements or functional groups are present. The quantitative to determine the amount, exact amount of the element present in the compound. And the spectroscopic and chromatographic methods help to reveal detailed structural features using physical data. Contain carbon, hydrogen, nitrogen, oxygen, sulfur, and the halogens. So elemental analysis begins with identification, and this identification we use Lassen's test, which is a classical qualitative analysis method that is used to detect the presence of nitrogen, sulfur, and halogens in organic compound. The procedure involves fusing organic compound with sodium metal to convert covalently bonded elements into their ionic forms, and then extracted and tested. First of all, you have to prepare sense extract. You take a piece of your dry sodium metal, heat it in a fission tube until it melts to a shining substance. Then you take a pinch of the organic compound that you want to test, add it, and the mixture is heated. Heat the mixture strongly to initiate that fusion reaction. And then, so that red hot fusion tube is plunged, you put it into a china dish that is containing distilled water. And the contents are washed with glass water, then heated to boil. In that solution you get filtered to remove any insoluble matter. And then that is the extract, the filtrate. This extract is Lassen's extract, which you're going to use for all your different tests. So to detect nitrogen, you take a portion of your Lassen's extract and a few drops of the freshly prepared ferrous sulfate solution. Heat the mixture, then add a few drops of ferric chloride solution acidified with concentrated hydrochloric acid. Then you observe. And you observe a Prussian blue coloration that indicates the presence of nitrogen. So the chemistry behind this is that sodium cyanide that is formed during fusion reacts with ferrous ions to form ferrocyanide ions. And then upon the oxidation, these ions form ferric ferrocyanide, which imparts the Prussian blue color. Then now to detect sulfur, we have two methods. One method is sodium nitrophosphate test. To the small portion of your lacense extract, you add a few drops of sodium nitrophosphate solution, and then you observe the purple coloration that indicates the presence of sulfur. The chemistry is that sodium sulfide that is formed during fusion reacts with sodium nitrophosphate to produce a purple color. Then you have the other method, lead acetate test. You take also a small portion of the lacense extract, add acetic acid to acidify it. Then you add a few drops of lead acetate solution. You observe the formation of a black precipitate that indicates the presence of sulfur. Hydrogen sulfide. Chemistry is that hydrogen sulfide that gas released during acidification reacts with lead acetate to form lead sulfide, which is black color. How to detect halogens? Take a small portion of the lacense extract, concentrated nitric acid, boil the mixture, cool the solution, then add silver nitrate solution. So for the different halogens, for chlorine, if chlorine is present, then you see a cordial white precipitate of silver chloride, which is insoluble in ammonium solution. If bromine is present, then you will see a pale yellow precipitate of silver bromide, which is partially soluble in ammonia. If iodine is present, you see a yellow precipitate of silver iodide, which is soluble in ammonia solution. And the chemistry is that sodium halides that are formed during fission react to silver nitrate to form the respective silver halides. It's something important that you should note, that presence of both nitrogen and sulfur in an organic compound can lead to the formation of sodium cyanate during the fusion. And this can result in blood red coloration when ferric chloride is added. So one can mistake it for positive nitrogen test. So to avoid this interference, you should first of all detect your sulfur before nitrogen. I'm going to put here 2 to stop sharing. Okay, to end it here today.